So as you can tell in this section, we are working with quadratic formula. So before you get all worked up and think, I'm never going to be able to do quadratic formula, I want you to know that I've kind of broken the quadratic formula down into a really simple method where you actually don't even ever write the entire formula down. So we do need to know the formula. So like Lady Gaga said, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the really important part of the quadratic formula, because it gives you all of the information that you need practically, is this section right in here. And it's got a very specific term, and we call that the discriminant. Not the discriminate, discriminant. And it gives us a lot of information. Okay? So if we can find that value, okay, so let's talk about this over here. Just that value inside there. If it's positive number, we don't care what it is. 1, 1,003, it doesn't matter. That means there's going to be two solutions to that, whatever your quadratic equation is. If it's 0, there's going to be one solution. And if it's negative, there's going to be what we call no real solutions. Remember we were talking last section about not being able to take the square root of a negative number? This is where that kind of falls into. There's no real solutions. There are solutions, but they are not real solutions. Okay? So what I want you to do when you're solving quadratic formula, this is my preference, I think it's much easier, is to get this bit of information first. So I want you to write down your A, B, and C values, because you need that information. Remember, those are the coefficients that we have going on there. Make sure that your quadratic equation is always set in descending order by the degree. So x squared, x to the first, remember this is x to the 0. So our A value is 3, our B value is 5, and our C value is negative 7. So I only want you to figure out the b squared minus 4ac. The reason I teach it like this is always where the problems come up with quadratic formula. It's really very rarely with this negative b or with the 2a. That part people can kind of noodle through just fine. But it's this in here that becomes problematic, so I've tried to kind of simplify that. So we're going to take our b value, which is 5, and square it. So that you can do in your head. Minus 4. And then what I'm going to do, instead of having these as separate values, A and C, I'm going to have you multiply those together. Because again, you can do that in your head. That's simple math. That would give you negative 21. Now we just need to shorten that up. So now we have 25. A negative times a negative is a positive. And 4 times 21 is 84. Once we add those up, our discriminant is going to be 109. So that is our discriminant right there. So right now I know I have two solutions because 109 is a positive number. But the easier part is that number is what goes under the square root sign. So now I just have to add on my finishing touches, as it were, which include my negative b. So you're going to take your b value and take the opposite of that, which would be negative 5, and double my a value, which is 3, so that would give me 6. And that's your solution. That's it. And so you notice we never actually wrote down this whole formula until the very end. So I think it's a much simpler way to go about doing quadratic formula. You can certainly start from here, fill in, and go as you wish. This, to me, simplifies the process by quite a bit and makes it not so intimidating. So now that we've got that, let's kind of talk about what that means. So we're going to go down here and practice writing our answers in decimal form, radical form, and then we're just going to see down here what we get. Okay? So the first thing I'm going to need to do on this, 9 plus or minus the square root of 739 over 6. So square root of 739 has an actual value, right? I don't know what that is, so because I'm doing it in decimal form, I know I can use my calculator. So I'm going to have 739, square root of that would be 27.18. Let's just round to the hundredths, like it says. So 27.18. So that would be 9 plus or minus 27.18 over 6. Well, what that really means is we have two And actually, I'm going to kind of center this up. Sorry about that. If you already have it written down, don't worry about it. 9 plus or minus 27.18 over 6. So what that really does is separates into two solutions, which would be 9 plus 27.18 over 6 and 9 minus 27.18 over 6. And now you can just solve those separately. So we're going to go, getting lots of bells today. 9 plus 27.18, total that, divided by 6. So that's going to be, so one of our values is 6.03. And the other value will be 9 minus 27.18 divided by 6. So that would be x equals negative 3.03. Okay, so those are going to be your two values there for that equation. Let's try another one with decimals. So let's try negative 17 plus or minus the square root of 319 all over 8. And I'm going to figure out what that square root of 319 equals, approximately. When you see kind of squiggly equal signs, that means it's approximately that much. It's not accurate. So square root of 319 is 17.86, roughly. And now I can use that to write my two equations. So I have negative 17 plus 17.86 over 8, and negative 17 minus 7.86 over 8. So remember, you're going to have two values for your solutions. So you're going to have 17 negative plus 17.86. Remember to hit the equals button before you divide. Plus 17.86 equals divided by 8 should give us 0.1, we'll just say 0.11 because it's 0.1075. And then negative 17 minus 17.86 divided by 8 would give us negative 4.36. There's your two solutions. Okay. So in some cases, you're going to need decimals because you're going to need to know where to go on your graph, right? So it's an approximation for your graphing purposes only. It's really the only reason you're going to switch them into decimal form is so that you can graph. All right, so let's practice now using just simplifying radicals. So let's get this 98 simplified down because that's the one we need to worry about. Well, that's the square root of 49 and the square root of 2. Remember, I want you using your perfect square, so let's one more time write those down. Hopefully they're becoming memorized at this point. So 1, 4, 9, 16, and 25, 36, 49, 64, 81, and 100, 121, 144, 169, 196, and 225. Okay, so square root of 49 is plus or minus 7. Square root of 2, I can't take any perfect squares out, so now square root of 98 and 7 square roots of 2 are equivalent. So now I'm just going to plug them in. Instead of square root of 98, I'm going to replace it with what it's equivalent to, which is 7 square roots of 2 all over 4. Now, here's an interesting thing that comes up. You can only simplify if there is a factor for all three terms, which in this case, we look at our whole number. So we have a 4, negative 6, and 7. Well, 7's a prime number. Nothing goes into it besides 7 and 1. So we can't simplify this any farther. Say this number was an 8. Well, a common number that comes out of 4, negative 6, and 8 would be a 2. So at that point, I can take a 2 out of each of these coefficients and simplify. But because that one is not factorable, they all three have to be factorable with the same number, and this one's not. Okay, let's try another one of those. So we have 12 plus or minus square root of 832. Boy, that 832 is sounding familiar to me, like we have done that before. Okay. And I seem to remember that 832, let's see if that's divisible by 16. Oh, it is, evenly. And then, so 832 would be square root of 16 and square root of 52. Let's double check that. 52 times 16 is 832, so far I'm good. 16 is a nice perfect square. 52, I can take a perfect square out, which would be 4. And I know that because in a deck of cards, there's 52 cards, 4 suits, and they each have 13 cards per suit. So, square root of 16 is 4. Square root of 4 is 2. And then I've got a 13 left. So that gives me 8 square roots of 13. So now I've got 12. I'll write that over there because I'm feeling I'm going to need some room here. So we'll have 12 plus or minus 8 square roots of 13 all over 2. So here's a perfect example. Look at my three terms that I have. I have a 2, an 8, and a 12. Well, 2 is a common factor of each of those. So I can definitely factor out a 2. And now all that I'm left with, this is a 1 on the bottom, so I have no fraction anymore. And I'm going to get 6 plus or minus 4 square roots of 13. So if you are able to simplify it with anything else in algebra, you always need to simplify that as far as you can get. Okay, let's try 2 more. Okay, so let's just see what this gives us. We're not sure. So let's see. Let's take that square root of 64. Oh, well, 64 is one of my perfect squares, isn't it? So square root of 64 is plus or minus 8. So let's see. I've got 4 plus or minus 8 all over 4. So when you get a whole number, if that discriminant is a perfect square, you're going to replace it with its square root. So square root of 64 is 8. So we're replacing that. We're substituting it with that value because they are equivalent. So what you have to do then is actually set up 2 separate equations, kind of like we did with the others, but these are going to actually give us whole number, maybe fractional answers, but not radical answers. So you would have 4 plus 8 over 4 and 4 minus 8 over 4. There's our positive 8, there's our negative 8. So 4 plus 8 is 12, divided by 4 would give us 3, and 4 minus 8 is negative 4, divided by 4 would give us negative 1. So our solutions would be x equals 3 and x equals negative 1. Okay? So you're either going to have radical answers that look like this, or whole, or something that has no radical left in it, just a standalone solution. Okay? All right, let's try one more of those. We have negative 5 plus or minus the square root of 144 all over 2. Well, I recognize the square root of 144 as being 12 over 2. So my two equations are going to be negative 5 plus 12 over 2 and negative 5 minus 12 over 2. So 12 minus 5 is 7 over 2, and we can just leave it just like that. That's perfectly acceptable. And negative 5 minus 12 is negative 17 divided by 2, which is just negative 17 halves. You certainly could change these to decimal form. They would make your graphing a little bit easier. Either way is completely acceptable. Okay, good job. Okay, so now once you get your equations, you want to remember too that quadratics always need to be set equal. Quadratics must be set equal to 0 to solve. They always need to be, because those x values actually give us where they're sitting on the x-axis. Okay, so let's see if there's anything that we can factor out of this. And I'm going to do this in a couple of different ways. So if we wanted to use quadratic formula, since we're in the quadratic section, we're going to say this is equal to 23. Okay, that's just a random number I'm choosing. But this equation now is not set equal to 0, and it needs to be. So the first thing I'm going to have to do is move this to the other side of the equation. So my new equation is going to be 12d squared minus 4d minus 23 equals 0. Now I can go ahead and pull out my a, b, c values and plug them in and use our quadratic formula in a nice, short, efficient way. So our a value is 12, our b value is negative 4, and our c value is negative 23. Okay, so again, we're going to use the b squared minus 4ac. That's our discriminant. So negative 4 squared is 16. 4, that's a little bit tougher. I don't know what 12 times 23 is off the top of my head. Times 12, and it's going to be negative 276 because I've got positive 12 and negative 23. Let's double check that. 23 times 12. Good. Okay. And so now I would have 16 plus negative times negative is a positive. 4 times 276 gives me 1104. So my discriminant is going to be 1120. Okay. Now we've got it. That's the part that's going to go under my radical. So let's see if we can get that simplified down a little bit first and see what we can pull out of there. Well, let's see if we can take a 4 out, divided by 4. Oh, that comes out. And actually another 4 is going to come out of there. So let's see if 16 comes out of there. 1120 divided by 16. Oh, it does. So that's going to be the square root of 16 and the square root of 70. So let's go ahead and double check that 16 times 70 really equals 1120. 16 times 70 is definitely 1120. The square root of 16 is 4. There's no perfect square that can come out of 70 because we only have 7 and 10. 7 and 10 is made up of 2 and 5. 7 is made up of 7 and 1. None of those are perfect squares. So here's going to be our simplest form. Okay. So now we can plug in the rest of our quadratic formula. So we're going to take the opposite of our b, which is 4, plus or minus 4 square roots of 70, all over 2 times our a value, which is 24. This is now simplifiable because 4 can go into 4, 4, and 24. So I'm going to simplify those down. So in radical form, we're going to leave it as 1 plus or minus 1 square root of 70. You can leave this second one off if you want to, over 6. But they also want it in decimal form. So let's figure out, now we're going to have to figure out what the square root of 70 is and give it an actual value. So 70 square root is 8.37. So that's going to give us, we can use the simplified version that we came up with over here, that's fine. So we'd have 1 plus or minus 8.37 over 6. So again, we can split that into two equations. And we get 1 plus 8.37 over 6 and 1 minus 8.37 over 6. Let's use the calculator. So 1 plus 8.37 divided by 6 gives us 1.56. And 1 minus 8.37 divided by 6 gives us 1.23. Good. So now we've got it in decimal form, simplest radical form, and that's as far as we can get that. Okay, we've got two more that we need to get to where they are not set equal to 0, that we have to make them equal 0 first before we can solve them. And the first one is going to be negative 3h squared plus 9 equals 8h. Again, remember that they must be set equal to 0. This is not equal to 0. If I can get that 8h to move, then it will be equal to 0. So when I move it, it's going to switch its sign because I need to subtract it from both sides. So I would get negative 3h squared minus 8h plus 9 equals 0. Now I can pull out my ABC values, which are negative 3, negative 8, and 9. And I can find my discriminant. So I would get b squared would be 64 minus 4 times 9 times negative 3 is negative 27. So I would get 64 plus, because negative times a negative is positive, 27 times 4 is 108, plus 64 is 172. Fairly sure 4 can come out of that. It can. So that's going to be my square root, but square root of 172. Actually, we don't even need to simplify that radical, because if I'm being told to find it in decimal form, let's just find the square root of 172. Save ourselves a step. And the square root of 172 is 13.11. So then my two equations would be, now we need to use the opposite of b, so it would be 8 plus or minus 13.11 divided by the double of a, which is negative 3, so that would give us negative 6. And my other equation would be the opposite of b. Remember what your quadratic formula is. Helps to write it down, just so you have it in front of you. Is 8. No, I made those into one equation. I should have made them into two. One is positive, and one is negative. So now we can just simplify those. So we've got 8 plus 13.11 divided by 6 negative would be 3.52, negative 3.52, sorry. And then we would have 8 minus 13.11 divided by 6 negative would give us 0.85. Okay. Our second example, they want expressed in simplest radical form, so we're just going to leave it in radical form, but we might need to simplify that radical. Again, we need everything off the right-hand side. So this 3's got to come over here, and it's going to do that by subtraction. So we would get 10n squared plus 8n. Negative 3 minus 1 is negative 4. Now that would equal 0. Let's get our a, b, c values. A is 10, b is 8, c is negative 4. So our b squared value is 64 minus 4 times 10 times negative, our AC value, so 10 times negative 4 is negative 40. So that gives me 64 plus 160, which is 224. Sure, I can take 4's out of that. Let's see if I can take 16's out of that. Oh, I can. So if you can take out 4's, then try and go ahead and see if you can take out 16's. You may or may not be able to. But that's our discriminant, which is going underneath the radical. So square root of 224 equals the square root of 16 and the square root of 14. Let's double check that. 16 times 14 is 224. The square root of 16 is 4. There's no perfect square that comes out of 14, so we're just going to leave it like that. And now we just need to add on the rest. So the opposite of our b value is negative 8 plus or minus 4 square roots of 14 all over double of our a value, which is 20. Now that can be simplified because 4 goes into each of those. So it goes in there once, in there negative 2, and in there 5. So our simplest form would be negative 2 plus or minus the square root of 14 all over 5. Oops. Sorry about that. Okay. So let's see what's going on with this equation down here at the bottom that we've got. Now, it doesn't really matter whether you've got your equation on the right side with the 0 on the left or your equation on the left side with your 0 on the right. Either way, it needs to be set equal to 0. So first thing I'm going to do is I'm going to move that negative 8 to the other side, and when I do that, it's going to become positive 8. So now I have 0 equals 2t squared minus 7t plus 8. So let's see what happens here. Let's just take our ABC value. So my A is going to be 2, my B is going to be -7, and my C is 8. So again, there's your discriminant. My B squared value is 49 minus 4. 2 times 8 is 16. So that gives us 49 minus 64, which is -15. Remember what we said. If I'm now going to try and put that underneath the radical sign, cannot take, as of right now, in a couple years in Algebra 2 you'll be able to, take the square root of a negative number. So here's a case of our discriminant was negative, so we can't take the square root of that. So what we say is there are no real solutions. And the real is important in there because that actually has 2 imaginary solutions, but you'll have to just wait in anticipation until Algebra 2 to figure out how that goes. So we're going to say no real solutions. And now you know everything there is to know about quadratic formula.